WAEC 2021 track question number 1. We are provided with meter rule, 2 without stands, this is without stand, thread, this is thread, stopwatch, this is stopwatch, and a set of masses. Mass is not necessary here. Measure and record the value of meter rule. The value of meter rule is 130 gram. Yes. The value of meter rule is 130 gram. Done the measurement. Tie one end of the thread to the meter rule at 20 centimeter. This is 20 centimeter mark, and one end of the other thread at 8 centimeter mark. This is 80 centimeter mark. Adjust the meter rule until balance horizontally, and so the distance between the base of the split block and meter rule are equal. Measure and record the distance between the vertical rule. The distance, the length is 80 centimeter. That is, the length from the base of the split cord to the meter rule is 80 centimeter. The same thing from here to that place is 80 centimeter. Now, measure and record the distance between vertical thread, which must be kept constant throughout the experiment. Suspend the meter rule with the graduated face upward. Let end of the thread be equal to 80 centimeter. A set of rule oscillates. Set the rule oscillating through a small angle 10 to 20 degrees, about an horizontal through the center. Determine the time t for 10 complete oscillation. Evaluate t squared log t log L. Repeat the experiment for value of L, 70, 60, 50, 40, and 30. Keeping the thread vertical of equal horizontal distance apart throughout the experiment. In each case, determine the corresponding values of t, capital T squared log t and log L. Plot the graph of log t against log L. Determine the slope, and state 2 precautions taken to ensure accurate result. Evaluate K is equal to S over Q, where Q is equal to 12 over 25 squared. Define simple amount of motion. Now we want to start. This length is 80 centimeter. This is the stopwatch. The first length is 80 centimeter. We are going to record it twice, T1, T2. Then we find the average later. Now, we want to start. As we displace the meter rule, at the same time we are going to start the stopwatch. So I want to start. This is at 80 centimeter. This is at 20 centimeter. Now I want to start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 17 seconds. Then we are going to repeat the same for the same length. We return it back. We displace it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The same thing, the same 17 seconds. Now, we are directed to reduce this by 10 centimeters from 80 to 70. 2, 3, 4. I'll check it. It's 67. It's 70. One, two. Let me check it. This is 71. Put it up once again. Okay, this is 17. So we want to start again. I want to start this placement again for length of 70 centimeters. Set. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 16 seconds. Then I'm going to repeat this once again. This length of 70. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 16 seconds again. I'm going to reduce it to 60 length of this 60 centimeter. 1, 2, 3. Measure it. Confirm it. 63. Check it. This is 63. So it is 60 now. I want to start this displacement once again. You turn it back. At the point of displacement, you start the stopwatch at the same time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 15 seconds for 60 centimeters. 15 seconds. Now, the third one, and we are going to repeat this one again. Make sure that the thread is at 20 centimeter here and 80 centimeter here. You want to start 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The value is 15 seconds again. Now we are moving to 50 centimeter, length of 50 centimeter. 1, 2, 3. Confirm it. This is 50. This is 50. And do the same thing here. Confirm it by checking it. This is 15. I want to start the displacement for 50. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 14 seconds for length of 50 centimeter. Want to repeat it, return back. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 40 seconds again for a length of 50 centimeter. And now reducing it to length of 40 centimeter. 1, 2, 3. Confirm it. This is 44. And reduce it. Now, this is now 40. Let's confirm it. Is 43. It's now 40. I want to start again. 40. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 13. This is 13 seconds. 13 seconds. Want to repeat the same. Return it back. Want to displace it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 13 seconds again. You want to reduce it to 12 to 30 centimeters. Okay, this is 30 centimeters. Let's confirm it. It's 34. Okay, this is now 30. Want to start again? Displacement 1, 2, 3, 4, 5, 6, 7, 8, 9, 12. This is 12 seconds. 12 seconds. Want to repeat it this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 12 seconds for length of 30 centimeters. Now, we want to find the average. To find the average, we had T1 and T2 together and divided by 2. So 17 plus 17 is 34. 34 divided by 2 is 17. 16 plus 16 is 32. 32 divided by 2 is 16. 15 plus 15 is 30. 30 divided by 2 is 15. 14 plus 14 is 20. 20 divided by 2 is 14. 13 plus 13 is 26. 26 divided by 2 is 13. The same thing with the last one. Now, we want to find T. Since it is 10 oscillation, capital T will be small t divided by 10. So this one, the first one is 1.700. The second one is 1.600, 1.500, 1.400, 1.300, 1.200. So T squared will be 2.89. T squared here will be 2.56. T squared here will be 2.250. 1.690. 1.96. 1.960. This one is 1.690. This one is 1.440. Log of T, log of 1.7 is 0.231. Log of 1.6 is 0.204. Log of 1.5 is 0.176. Log of 1.4 is 0.146. Log of 1.3 is 0.114. Log of 1.2, 0.079. Now, log of log of 80. Log of 80 is 1.903. Log of 70 is 1.845. Log of 60 is 1.778. Log of 50 is 1.699. Log of 40 is 1.602. Log of 30
is 1.477. Meanwhile, if you get values less than around 9, 8, or 7 for this average, you are going to get negative value for T. You are going to get negative value for T, and it will be reflected in the graph. Now, let us plot the graph. We are directed to plot log of T on the vertical axis against log of L on the horizontal axis. So the minimum value of log of T is 0.079. We are going to plot to 2 decimal places. This will be 0.08, 0.11, 0.15, 0.18, 0.20, 0.23. Against log L, the minimum value is 1.448. We are going to plot to 2 decimal places. The maximum value is 1.9. So 1.48 against 0.08, 1.60 against 0.11, 1.70 against 0.15, 1.78 against 1.77, 1.85 against 2.0, 1.90 against 2.3. Let us start. First one, 0.28 against 1.48. This is 0.5. So, if this is 0.5, this is the 0.6, 0.7, 0.8. 0.8 against 1.48. This is 1.5. So, this is 1.0, 1.2, well, okay, 1.1, 1.2, okay, 1.2, 1.4, 1.6. So 1.48 will be in between here, 1, 2, 3, 4, 5. Now, 0.11 against 1.6. This is 0.10. 0.11 will be on the second square against 1.6. 1.6 will be here. 1.6 will be here. 0.15 against 1.7. 0.15 against this 0.15 against 1.7. 1.7 will be here. The next one is 1.78, 0.18 against 1.78. 0.18, this is 0.15, 0.16, 0.17, 0.18 against 1.78. This is 1.5, 1.6, 1.7, 1.78, 1.8. And bring it up. 1, 2, to be here. Then 0.20 against 1.85. This is 0.20, 1.85 to be here. 0.23 against 1.90. This is 0.20, 0.21, 0.22, 0.23 against 1.9. 1.9. 1.9 will be here. 1.9 will be here. So this is our graph. I'm now going to join them together. I'm going to join them together now. It's called 1, 1, 1, 2, 3. Called 3 points. Remaining are evenly distributed, 1 here, 1 there. So that is the graph we are directed to plot. Determine the slope. We are directed to determine the slope. We have to draw a right angle before we can determine the slope. So give us, let's use this one against this. This will be y2, this will be y1, this will be x2, x1. So we're about to do the slope. Our slope will be y2 is 0.25, y1 is 0.05, 0.05, x2 is 2.12345, 2.5, x1 is 1.1. So 5 minus 5, 0. 2 minus 0, 2. 0.20. 5 minus 1, 4. 2 minus 1, 1. 2.2 divided by 1.4. 0.2 divided by 1.4 is equal to 0.143. That is our slope. Precaution, our further parallels error on meter rule. I also noted and corrected 0 error on stopwatch. We are directed to evaluate K. Here K is equal to slope all over Q. And Q is equal to 2 all over 25 d squared. So this one will give us 2 all over 25. Our D is the distance between the two lines. The first one was at 20 centimeters at the beginning here. The second thread is at 80 centimeters. When you subtract 20 from 80, you get 60. Our D is 60 squared. So this one will give us 2 all over 25 times 60 times 60 is 3,600. So this one will give us 2 all over 25 times 3,600 is equal to 90,000. times 2. This is equal to 0.0001234 0222. This is the value of Q. This is the value of Q. K is equal to S all over Q. So our slope is 0.143 divided by 0.00002222. So this one will give us this is times point 143 6,435 is equal to 6,435.00. Simple harmonic motion is the periodic motion of an object or a particle such that the acceleration is directed toward a fixed point and is directly proportional to the displacement.